Okay, as we continue with congruence theorems, in section 12.1, we looked at a couple of constructions, and we just started those constructions of an angle bisector, copying an angle, copying a segment, and a segment bisector or perpendicular bisector. We also talked about some congruence theorems, how to show triangles are congruent. And I do recommend, if you have a printer, print out this template on some of the notes that we're going to take, and then you can kind of follow along and fill it in. Otherwise, of course, I'll be writing them down for you, and ultimately they are in the book. So this is what we're going to be taking a look at today. We're going to take a look at starting some proofs and going through some of the congruence theorems. All right, so to start us off, let's kind of recap what we did last time when we started talking about congruence theorems. So theorems, which remember are mathematical laws or rules that have been proven, theorems to show triangle congruence. We have the ones that we went over the other day. We have the side, side, side theorem, which just says if all three sides of one triangle are congruent to all three sides of another triangle, then the triangles themselves are congruent. And remember, congruent means all angles are the same, all line segments are the same. So all angle measures are equal, all side lengths are equal. Then we also had side angle side congruence, which said if I give you two triangles, and if two sides and an included triangle of one triangle are congruent to the corresponding two sides and included angle of another triangle, respectively, then the two triangles are congruent. And then we had the third one, the hypotenuse leg triangle. Well, since it's got a hypotenuse, this has to be right triangles, because that's the only kind of triangle that has a hypotenuse. So all three of these were covered in section 12.1. Now we want to add to that two of them. We want to add angle, side angle, and we want to add angle, angle, side. And these are the two that we can find in this section. All right? And then after we go through those, we're going to practice doing some proofs. Oops, sorry about that. So let's first start with angle, side angle. So angle, side angle theorem. It says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, respectively, then the triangles are congruent. We have two angles and the included, so it's got to be between them. Of one triangle. Are congruent to two angles and the included side respectively. Then the triangles are congruent. So let me draw a picture and just show you, we'll sketch what that would look like, okay? So the idea is, if I have a triangle and I have a triangle, and we can show, or we are given that we have two sides and the angle between them. All right, so I know these two are congruent because they have the same congruent mark. I gave them one hash mark. I know these two sides are congruent because I gave them the same double hash marks. If the angle between them is also congruent with the same congruent mark, then I know that by angle side angle, these two triangles are congruent. All right, so that's what that one looks like. Now the other one is called AAS, which would stand for angle, angle, side. So the angle, angle, side congruence theorem. All right, so now if two angles and the side opposite one of those angles are congruent to two corresponding angles and the corresponding side of another triangle, then the triangles are congruent. Okay. So if two angles and a side opposite one of the angles, okay, are congruent to two corresponding angles and the corresponding side of another of a triangle, are congruent to the corresponding angles and side. Of course, we're talking about the side opposite one of those angles. Then the triangles are congruent. So again, we'll draw a picture of what this would look like. Angle, angle, side. So if I have, just sort of try to draw these a little bit. An angle, so I'm going to mark it differently, and not the side in between them. Otherwise, that would be angle, side, angle. I just gave you side, angle, side. I'm going to have to change that in just a moment. Here I have two angles and a side opposite one of them are congruent to their corresponding two angles and a side opposite, then these two triangles are congruent. So if this is triangle ABC and this is triangle DEF, we would say that triangle ABC is congruent to triangle DEF by angle, angle, side. And I apologize. There's nobody here to have caught me while I was writing it. Some of you watching this might be like, wait a minute. This says angle, side, angle. I accidentally showed you side, angle, side. So let me correct that right now instead of starting completely over. okay? Angle, side angle. So two angles. Here's an angle, here's a separate angle with a different congruent mark. Here's an angle, here's a separate angle with the same congruence marks. And the side between them. Notice it's even physically located between angle, side angle. So this side is between these two angles, and it's denoted with the same construction mark. So those congruence marks are the same, D, E, F. So we could say triangle ABC. Remember, we write them in the corresponding same way. So A corresponds to D, B corresponded to E, and C with F. And we would say that these are congruent by the angle, side, angle congruence theorem. And it's okay to just say angle, side, angle. We're only going to be doing a few theorems in this class, so you can abbreviate them the same way I've got them here. All right, we're not going into every theorem out there, but we are going to touch on a few. So let's take a look first at some identification. So I'm actually going to jump, if you're following along with the notes template. Since we just talked about the congruence, I'm actually going to go to the very last page that I gave you. I'm going to go to the very last page. And I want to practice a few. Okay, so on the very, very last page are a few pictures. I'm going to draw these on the board, and let's see if we can figure out if the triangles are congruent. All right. So now that we have them all listed, side, 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 a side and two angles with the angles between them, hypotenuse leg, angle, angle, side with the side between the angles, angle, angle, side where the side is not between the two angles. So I'll leave these listed so we can take a look at them. So let's first identify and practice through observation what each one might look like, and then we'll start some proofs. So here's our example. All right, determine if the two triangles are congruent. All right, if they are, how do you know? So state how you know, justify your response, in other words. All right, so I'm going to sketch a few pictures here. First one, kind of looks like starting with an X. If you have the notes template, it's going to be a lot better than my sketch. But one thing about geometry is never assume. Always look at what you're given. So don't look at a perspective and say, oh, it looks a certain way, therefore it is a certain way. So everything, I'm going to give you everything in black ink, and then we'll write anything else we can figure out in blue ink. So I'm going to give you that. This angle and this angle have the same construction mark. therefore they're congruent, so they have the same congruency mark. And this side have the same congruency mark. So right now I have an angle and a side. So right now, side, side, side probably doesn't work. I want to look at side, angle, angle, or angle, angle, side. Now if I analyze this, I don't know anything about these lines. Okay? If I knew the lines were parallel, then I could use alternate interior angles. But I don't know anything about that. But I do recognize that this angle right here and this angle right here are actually congruent. How do I know that they're congruent? Well, I know that they're congruent because we've identified those in the past as vertical angles. Okay? So since we have vertical angles, and I'm just going to put that in here, vertical angles are congruent. If we were face to face, we'd be having this discussion together. So now look at what we have. We have an angle, a side, and an angle. And we have an angle, a side, and an angle where the side is between the angles. So these would be congruent by angle, side, angle, triangle congruence. So they are congruent by angle, side, angle. Another picture, see if I can try to draw this one. I gave you these two sides. I gave you a third side. And I gave you, okay? Now the other pieces of information I gave you, this side is congruent to this side. This line segment is congruent to this line segment. And that's all you've been given. So I want to try to show that this triangle on the left is congruent to this triangle on the right. So I have no angles that are given. I didn't give you a single angle. So this one's out, this one's out, this one's out. So the only two that are potentially could be are side, 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 or hypotenuse leg. I did not give you a right angle. This might look like a right angle, but unless you see the mark, you cannot assume it's a right angle. Because we now know that that could be 89 degrees, 59 minutes. So it could be really close to 90. So do not assume it's a right angle. So that means this one's out because there's no angles. This one's out because there's no hypotenuse, and this one's out. So it's got to be side, side, side. So you'll notice that they both share a side. Both of these triangles, whether it's on the left or the right, they both share this common side. So I put a little check mark there. They share a common side. So by sharing a common side, I can say that this side equals itself. So that's a reflexive property. When you look in the mirror, you see a reflection of yourself. It's the same thing. So these share a common side. So we refer to that as the reflexive property. It's a reflection, okay? They both share the same thing. So no matter if I'm looking at that segment from the right side or the left side, we're talking about the line, same line segment. So we can say that these are congruent by side, 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 triangle congruence. Let's try a third one. It looks like I kind of went up and I kind of went vertical, then I went horizontal, then I sort of went kind of like that. And I gave you, this is a right angle. I gave you, this side is congruent to this side of the other triangle. I gave you, this side is congruent to this side of the other triangle. And we need to figure out whether there's enough information to determine if these two triangles are congruent. Well, again, did I give you any angles? And the answer is yes. I gave you this right angle, and I also gave you the opposite or vertical angle, so I know this one is also a right angle. And you'll notice we have an angle and two sides. Here I have an angle and two sides, but the angle has to be between the sides. This angle is not between the sides. In fact, it kind of spells that out. This is a side, and an angle. We do not have a side-side angle congruence. But it's a right triangle. If it's a right triangle, look for hypotenuse and leg. Well, the hypotenuse is always across from the 90 degrees. It's the longest side. We have both hypotenuse. We also have one leg. So since these are right triangles, I'm just writing down observations. We have the hypotenuse leg theorem, triangle congruence theorem. Part D, I gave you the picture up like this. Remember, the drawing doesn't have to be perfect, and comes down like this. Always go off of the construction and congruence marks. So I gave you this angle is congruent to this angle, and I gave you this angle is congruent to this angle. Just make the construction or congruence marks the same. So right now, the only thing we have are two angles. So it cannot be side, side, side. Side, angle, side. Side, angle, side. I don't have another side. It's not a right triangle. Angle, side, angle. Angle, side. I didn't have this one. Angle, angle, side. But notice again, do they share a side? And the answer is yes. They share this side right here. So that's a reflexive property again. That's a reflexive property of segments, which means that any segment is congruent to itself. So I always like, as I said up here, I always put like a little check mark. It's just the way I do it. It's not the way it is done. It's just the way I do it. So now notice we have an angle and a side that's not included. Meaning I have an angle and a side that is not between them. I have an angle and a side that is not between them. Therefore, I have angle, angle, side. And we'll look at two more before we start looking at some proofs. All right. I gave you a triangle. I'm just going to sketch these. and I gave you this side, and an angle between them. And then I gave you, oh, this picture doesn't look anything like the other one. I gave you, so maybe it's a rotated shape. I gave you this side, and this angle. So it looks like on the first triangle, I have a side, an included angle, and a side. So it looks like I have side, angle, side. Do I have the exact same thing on the other triangle? If I go from the side with 1 mark to the angle to the side with 2 marks. If I go with the side with 1 mark, an angle, I should have a side with 2 marks on the other side of that angle. So they have to look like they go in the same order. 1 mark, included angle, 2 marks. 1 mark, included angle, well, the 2 marks should be over here. So in this case, we don't have enough information. We cannot deduce that they are congruent. Not enough information. To decide congruence. And then the last one, and I'm going to sketch it again freehand. Side, and we are given this side is congruent to this side. We are given this angle is congruent to this angle. Do we have enough information based on our 5 theorems to determine if these 2 triangles are congruent? We have a side and an angle. So it's probably not side, side, side. If we have a side and an angle, look to see if there's another side surrounding the angle. We have a side and an angle. Look to see if there's another angle surrounding the side. We have a side and an angle. Look for an angle that's not surrounding the side. So right now, I do see that they share a side. And remember, anytime they share a side, they are congruent to each other. And now I have side, angle, side, side, angle, side. So this is by side, angle, side, triangle congruence. All right, so that was just a practice of identifying them, because we're now going to use those to start proving some other theorems and to start doing some basic geometry proofs. Now, when I say basic, that doesn't mean easy. When I say basic, it means we're just going to use the terms that we've done so far. All right. Okay, so we're going to use these. We're going to keep, I'll keep them listed over here. And I'll kind of, so those are still there just so we can refer to them. And we're going to start looking at a proof. Okay? Now, to do a basic proof, to prove in geometry, we are able to use, and we've kind of done this before, I think, but I apologize if we haven't spoken about it lately. We can use any theorem that's already been proven. We can use definitions. We can use constructions. We can use postulates or axioms. and a postulate or an axiom is assumed true. Okay, so if we assume it's true then we can use it. If we know a definition, of course, that always works. A theorem has already been proven. So we're going to use a combination of these things to do some proofs. So the first proof, the first one I want to do, is show that the angle-side-angle congruence theorem can be used to prove that the opposite sides and opposite angles of a parallelogram are congruent. Now, I also want to refresh your memory of the other day, we said CP, C, T, C. Corresponding parts of congruent triangles are congruent. All right. So what we want to do is, here's our first proof that we're going to try. We want to show that using the angle-side-angle theorem, we can prove that the opposite sides and opposite angles of a parallelogram are congruent. So we want to prove opposite sides and opposite angles of a parallelogram. I'm so sorry, that's off the page a little bit. Opposite sides and opposite angles of a parallelogram are congruent. So that's what we're trying to prove. So we're going to do a two-column proof. There's a lot of ways you could do a proof. You can do a flowchart proof. You can do a paragraph proof. In this class, I'm only going to focus on a two-column proof. If you are familiar with proofs and you are comfortable doing a paragraph or a flowchart proof, feel free to do that. Okay? But a two-column proof, first of all, has two columns. On one side, it gives you a statement. On the other side, you provide the reason. And that reason can be, again, a theorem, a definition, a construction, a postulate. But the one thing we always start with is we always start with a given statement. Always. Always, 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 always start with whatever's given to you. And in this case, we are given a parallelogram. So I'm going to start with ABCD is a parallelogram. The reason? It's been given. So I'm very visual. I'm going to out here sort of draw a parallelogram. I'm trying to sketch one here. Okay, it's a little crooked, but here's A, here's B, here's C, here's D. So I'm starting with a parallelogram. Now, because it's a parallelogram, and when we looked at parallelograms last chapter, we know that because it's parallel, the sides are parallel. So I can say step 2, side AB parallel to side DC. And I can also say that side AD is parallel to side BC. Now the reason I know that to be true is we know this is a parallelogram. So I can say, all right, I know that's true by definition of a parallelogram. So now that I know it's true, I'm going to go ahead and put my parallel line marks. So we know AB and DC. So I now know AB and DC are parallel. And I also know side AD is parallel to BC by definition of a parallelogram. Remember, we're trying to prove that the angles are congruent. We're trying to prove that the sides are congruent. So now, what I'm going to do is a construction, okay? I'm going to put a construction in and help you. And for now, I'm going to give you the parts and pieces. I am going to construct a diagonal. So I'm going to construct the diagonal from A to C. And I'm just going to say line segment AC is a diagonal by construction. So what we've actually created is we've now created a transversal. We now have two parallel lines that are cut by a transversal. So all those angle measures that we learned before are going to apply. Okay? And I do know that since, take a look. See how I have two triangles? Don't they share a common side? So now I know that AC is equal to itself. You'll see why that comes in just a moment. AC is congruent to itself. Because I'm starting to create what I need to show congruence. The reflexive property. Of segment equality if you really want it. The reflexive property is fine. Now because this is a transversal, and you may want to refresh your memory because it's a transversal, I can start looking at angles. For example, I can look at angle BAC. BAC. This angle right here, now notice I have two parallel lines cut by a transversal. These two parallel lines are cut by AC, which means this angle right here, DCA, is congruent to BAC. From B to A to C. B to A to C. So B past the one parallel, A to C. So that would be DCA. By the same argument, I could do the other side. Looking at the other two parallel lines, so I could say angle DAC, D to A to C, would be B to C to A. And both of those are alternate interior angles. know those are congruent. So what do we have right now? Right now we have, oh wait, I think we might be done. Because look, we have, if I'm looking at these two triangles, we have an angle, we have a side between them that they share, and we have another angle. So I have angle, side, angle. Angle, side, angle. Blue angle, line, green angle. Blue angle, line, green angle. So I now have two congruent triangles. Triangle A, B, C, so go in the same order. A to B to C would have to be C, D, A. And this works by angle, side, angle. So why do we do that? Well, because now that I know the triangles are congruent, everything about them, all their corresponding parts have to be congruent. So at this point, if I want to say opposite sides, okay, we want opposite sides congruent, let's list them. AB is congruent to CD. Now remember, you can also just look at these triangle parts. AB, CD. You can also say, I lost my place. AD is congruent to CB. So I believe we just showed that opposite sides were congruent because corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Well, we're also supposed to show that their angles are also congruent, the opposite angles. So if I look at opposite angles, then I can say the only one left, because I've already proven the other ones, so the only angle left, ADC, is congruent. Remember, I could just look up here. ADC, that would have to be CBA. And again, corresponding parts of congruent triangles are congruent. So I have now shown that the opposite sides are congruent, and I've now shown that the opposite angles are congruent. Okay. Let's try one more proof together. And then I did type up for you a bunch of theorems about quadrilaterals. They are in the book, but I also typed them up for you. So if you printed out the template, you'll see them on there. But let's try one more proof together, and then we'll call it a day. All right? All right. Let's try this next one. The other one I am looking at is we want to prove that the diagonals of a parallelogram bisect each other. Prove diagonals of a parallelogram bisect each other. So again, we're given a parallelogram. So I'm going to start with a sketch of a parallelogram. Okay, we started, the next section we'll actually go through and learn how to construct a parallelogram in the form of a rhombus. But for now, let's start with a pictorial idea. And we'll do a two-column proof. I'm just going to sketch this for our purposes so that we can kind of draw on it. We are given, and I'll go this way, a parallelogram ABCD. Okay? And we want to prove that the diagonals bisect each other. So let's start with what we're given. Let's do a two-column proof. I want to make sure I have enough room here so you can see. Always label your columns. So in this case, we always have a statement and a reason. And my favorite is the very, 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 very first statement and reason. The first reason we always want to use is whatever's given. So again, the only piece of information we're given is if we have a parallelogram, then the diagonals bisect each other. That's the theorem we want to do. We want to write that as a conditional statement. I'll say it again. As a conditional statement, if a quadrilateral or a polygon, if a polygon is a parallelogram, then the diagonals bisect each other. So let's start with the given. We are given ABCD is a parallelogram. Our goal is to bisect the diagonals. So the first thing I'm going to do is I'm going to construct two diagonals. So I'm going to say AC is a diagonal. How come? Because I used my straight edge to make them a diagonal. I'm going to do the same thing with BD. I'm going to use my straight edge to construct that diagonal. Oops, no I. There we go. Sorry about that, by construction. Okay. Now, what's cool is we want to bisect. We want to show that this line segment is congruent to this line segment, because then they bisect each other. And we want to show that this line segment is congruent to this line segment, because then they bisect each other. So I am going to, let's see, we've used the letters A, B, C, D. So let's make this point of concurrency, let's make this point of intersection E. Now, we just got finished proving something about parallelograms. We just got finished talking about opposite sides of parallelograms are congruent. So I'm going to start there. I'm going to start with where we left off. Okay? So let's start with what we just did a minute ago. opposite sides of a parallelogram are congruent. So let's label that. And I'm going to switch colors a little bit. Maybe it'll make it a little bit easier. Okay. So first of all, I'm going to say, okay, AB is congruent. AB is congruent to DC. What are the other two opposite sides? Well, we also know that AD is congruent to BC. That's the theorem we just proved a minute ago in the last example. Okay, so I now have, if I pick a pair, if I pick these two triangles or these two triangles, I need to show they're congruent. If I can show they're congruent, then corresponding parts are congruent. All right? So let's start with maybe triangle, if I started with this one, let's start with AEB. Let's go with angle AEB. What angle is angle AEB congruent to? Well, we know it's congruent to its vertical or opposite angle. So AEB would be congruent to CED. Because these are vertical angles or opposite angles. All right, vertical angles are congruent. Now, what else do we know? Well, if I do the same idea, AED would be congruent, AED would be congruent to CEB. AED A to E to D. So that would be C to E to B. Same reason, vertical angles. So I'll put them in the same number because it's the same reason. So now I have an angle. Well, don't we know the lines are parallel because it's a parallelogram? If we know the lines are parallel, then we have a transversal. So if I have two parallel lines, they're cut by a transversal. So I know alternate interior angles. If I have these two parallel lines, they're also cut by a transversal, so I have alternate interior angles. So we have all kinds of alternate interior angles. So let's just sort of start at the beginning and figure out which one we want to look at. Let's say I go from B to A to E. That would be congruent. Well, if these two sides are congruent, parallel, here's my transversal. That means that this angle would have to be congruent. So if I went from B to A to E, I need to go D, C, E. Alternate interior angles theorem. Do we have any other alternate interior angles? Well, if I look the other way and I'm trying to compare the others, I also have DAE. All right, I can go from D to A to E, and DAE would be the same as BCE. Let's see, D to A to E would be the same as B to C to E. Same argument. Yep, if that one's here, that one's here. Well, notice what we have. If you focus on the blue triangles, if you focus on the ones that are top and bottom, you'll notice we have an angle, and a side that's not between them. Down here we have an angle, and we have a side that is not between them. So we have shown that triangle, and I'm sticking with the blue here, BAE is congruent to triangle DCE, right angle, angle, side. Now do it again with the ones that I have in green, the ones on the left and the right. The ones on the left and the right, notice I have an angle, and a side that's not between them. I also have, I forgot to put the vertical in here, I also have an angle, and a side that's not between them. So this will also follow. Okay, pause that for a second. All right, so if I focus on just the green or just the blue, I think we've shown that these are also congruent. And now we can start listing corresponding parts of congruent triangles are congruent. So if I stick with the ones that first start in blue, I can now say AE is congruent to CE, or if I look at the other direction, I can say DE is congruent to BE. So this one is congruent to this one. Why? Corresponding parts of congruent triangles are congruent. So if we look back at our conditional statement, if a polygon is a parallelogram, then the diagonals bisect each other. And so we were able to prove that. It'll take a while to get into these. You may want to look at it once or twice, okay? And we will definitely try to practice some more of them, but at least that gets you started. So until next time, I'll see you guys later.